Hey guys, welcome to Conceptual Geometry, Lesson 5.3, Slope of Parallel and Perpendicular Lines. So, what do you know about parallel lines? Let's take a look at a couple. Try to plot the same points I plot here. I'll start with -3, -3, -1, 0, and 1, 3. And to the best of your ability, sketch in that line. All right, next I had 1, -4, 3, -1, and 5, 2. So they have the same steepness. Now, obviously, steepness isn't really a math term. What does it mean to have the same steepness? Well, check this out. Going from this point to this point, I went up 3, right 2. And that was the pattern for this line, up 3, right 2. The red line, up 3, right 2. Up 3, right 2. So we say they have the same rise over run, or what's that word? Slope. So that's the key for today's lesson, one of the keys. Parallel lines have equal slopes. Now, we're not going to be graphing all of these. You need to determine this algebraically. So we're going to use our slope formula. I'll remind you of what that is right here. In today's lesson, on two different lines and determining, are they equal? If so, they're parallel. Are they not equal? If so, not parallel. So it's a pretty simple task, just a little bit of work. Example 1, find the slope of AB and CD. Are these lines parallel? Why? So again, a quick refresher from last lesson. The first coordinate is x1, y1. The second coordinate is x2, y2. I just want to plug into that slope formula up above. So I'll have 6 minus 7 over 4 minus 7. 6 minus 7 is -1. 4 minus 7 is -3. Remember, if you have two negatives in a fraction, they cancel out. So the slope of AB is simply 1/3. All right, and actually, I should have started that with slope of AB. We need to get used to this notation. We're going to be using it quite a bit. We are going to get into some proofs in which you have to denote what segment you're finding the slope of. All right, so the second one, slope of CD. Y minus y, 1 minus 3, over x minus x, 2 minus 8. 1 minus 3 is -2, 2 minus 8 is -6. So not only do we have to cancel those negatives, but we have to simplify that fraction. You're welcome to use a calculator to do this, but I think that's pretty straightforward. Just divide both by 2 and you get 1/3. So now the question is, are those two equal? And bingo, yes, they are. So to answer the question, are they parallel? Yes, because they have equal slopes, or they have the same slope, however you want to word it. All right, next example. PQ, so let's find the slope of PQ. That will be y minus y, in this case 1 minus 4, over x minus x, 4 minus 9. So 1 minus 4 is -3, 4 minus 9 is -5. That slope is 3/5 when you cancel the negatives. And the slope of RS, -2 minus 3 over -1 minus 2. So -2 minus 3 is -5, -1 minus 2 is -3. That is 5/3. Although close, those are not equal. 3 over 5 is not the same fraction as 5 over 3. So since these are not equal, I would say no, because they do not have equal slopes. So that's how you determine parallel versus not parallel. Now let's take a look at perpendicular. What do you know about perpendicular lines? Well, obviously the basic thing we know is they form right angles. Well, how do we determine that on a coordinate plane? Once again, I want you to sketch in two perpendicular lines. We're going to have to follow this. It's hard to do on a grid, but we'll start with the point -3, -4, -1, -1, and 2, 1. And then we also can actually get in 3, 5. So sketch in that line. I will label this line M. Okay, so then I used -4, 1. And I determined this ahead of time. That's why I know these are right angles. -1, -1 again. 2, -3. And then this point right here, 5, -5. And then sketch in that line to the best of your ability. And I'll call this line L. So like I said, I determined this ahead of time. I know that those form a right angle. So let's take a look at slopes. Slope of line M and the slope of line L. So the slope of line M is up 3 over 2. Let's make sure that continues. Up 3 over 2, yes. So that slope is 3 over 2. The slope of line L goes down 2, right 3. Down 2, right 3. That's -2/3. Well, clearly, these are not equal. So what makes these perpendicular? Well, how would you describe these two fractions right here? They both have a 3. They both have a 2. One's positive, one's negative, and it looks like I flipped the one fraction to get the other. We call these opposite reciprocals. So perpendicular lines have opposite reciprocal slopes. All right, so we're going to try a couple examples here. Now I'm going to ask you, are these lines perpendicular? Why or why not? So first, let's find the slope of AB. Y minus y, 6 minus 8, over x minus x, 4 minus 7. 6 minus 8 is -2. 4 minus 7 is -3. Remember, we have to write this as 2/3. If there's two negatives, they cancel. All right, the next one, the slope of CD. Y minus y, 4 minus 7 over x minus x. We have to be careful here. 1 minus -1. 4 minus 7 is -3. 1 minus a -1. Remember, those negatives cancel. That's 2. So now compare. What do you notice about these? They are indeed opposite reciprocals. It's actually the same example we did up above. So I would say something like, yes, they are perpendicular because they have opposite reciprocal slopes. You have to use both of those words, obviously. You can't, one of them is not good enough. Just opposite doesn't work. Just reciprocal doesn't work. They have to have opposite reciprocal slopes. Okay, one more example, last one. Okay, so I need to find the slope here of PQ. Y minus y, 1 minus 5 over x minus x, 4 minus 9. 1 minus 5 is -4. 4 minus 9 is -5. Cancel those negatives, 4 over 5. Pretty straightforward at this point, finding slope. Next, slope of RS. Y minus y, 2 minus -2. Yeah, watch out for those negatives. Over 2 minus 7. So 2 minus a -2 is 4. 2 minus 7 is -5. So let's take a look. Close. They're opposites, but 4 over 5 is the same as 4 over 5. They're not reciprocals. They're just opposites. So in this case, I would say they are not perpendicular. No, because the slopes are not opposite reciprocals. All right, so that's today's lesson. Parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. So we need to be able to keep those two straight. We'll use the slope formula for everything, but we need to understand what equal slope tells us versus what opposite reciprocal slope tells us. And if it's neither one of those, then the lines are not parallel, nor are they perpendicular. So we'll end up seeing some questions. They'll say, are they parallel, perpendicular, or neither? So basically those three scenarios. Thanks a lot for watching, guys. As usual, reach out if you have any questions, and see you in class soon.